Hello, my name is Lizette Malgoza, and this is my COGS180 Teachback 2. So here's an outline of today's presentation. I'm going to summarize and highlight key points of the reading selected, propose my independent research, which is mirror neurons, and give insight and value of my independent research. So the reading I chose is by Welsby and Pexman, and it is the Developing the Embodied Cognition Insights from Children's Concepts and Language Processing. And let me hold on, sorry. The next one. So here in the reading, it defines embodiment cognition as the theory that emphasizes the importance of sensory motor experience gained through our interactions with the world. So it also mentions that sensory motor interactions is essential for gaining our knowledge and developing our cognitive abilities. When language is comprehended, it stimulates meaning in the words and the sentences. There are a variety of embodiment cognition theories that fall into the spectrum between strongly embodied and disembodied. This spectrum of embodiment cognition theories is regarding the relationship between sensory motor and cognitive processing. The purpose of this paper is to review the developmental theories and evidence of recent development literature, highlighting the importance of sensory motor experience. Sensory motor here is defined as the experience involving action performed, the ability by children or through observation. So in this section, it just talks about the importance of sensory motor experience and development, especially that of the work that has been essentially done by Piaget. And he emphasized that sensory motor information initially drives cognitive development, and that experiences are essential for the aspect of learning, and later cognitive processing developed from these sensory motor abilities, naming that this is just the baseline of what cognitive abilities are to come. So the reading mentions that given the results from adult studies, sensory motor knowledge is beneficial for motor and action development through a kid's childhood, as well as language and higher order cognitive functioning in school ages in children. This review includes a study by Bornstein et al. In 2010, where they found that higher scores of motor exploration was correlated with the higher scores of intellectual and academic measures when they reached the ages of 4, 10, and 14 years old. So basically suggesting that there's a positive long-term outcome because there can be enhances with their vocabulary, attention, and knowledge. So this next section just explores the early sensory motor experience of children, concepts, and word learning, the three types of words, basically the nouns, the verbs, and the adjectives. These are just bulleted points of the findings, and I'm going to go ahead and try to my best to just read through them and provide the key points from these sections. So basically, sensory motor experience has helped with the ability to differentiate between objects and words. It also helps with the way children try to conceptualize representations. So they found that the way children manipulated and acted upon an object basically comprised part of the conceptual representation of the actual object. Also, the way objects are held and manipulated influences aspects of object relevant for categorization. Interestingly, spatial learning also has an important role. So spatial learning and body positioning influence word learning. And then this is also extended in this section of nouns. They extended also to robots, which is robot categorization performances were comparable to the children's. The next section talks about verbs, and overall, it's basically saying that children's understanding of verbs are grounded in bodily actions and sensory motor experiences. They also mentioned that there's different brain regions areas depending that are activated depending on how the children basically learned those verbs. Um, Another thing that's mentioned with the verbs is that sensory motor movements evoked while when learning reactivated during recognition. Finally, the adjective section is a study found that observation description is beneficial to teaching activities. So tactile experiences were essential for meeting, and that there was a positive correlation between performance and interaction, and their interaction with their tasks. So, for example, the higher the children was in their performance, the higher the children's tactile interaction was for the task. So for this next section, the influence of sensory motor experiences on language processing basically talks about the comprehension of the story and how if they're able to best recall the stories and their events. Um, and it's basically found that um, conceptual knowledge of the whole story basically enhanced when interacting with objects that represent the story information. And older children construct of objects or stimulations in implied sentences as well. Some of the issues that were basically kind of, I guess, limitations to this, all of these like articles provided is that the sensory motor experience was a little bit too broad. I the best suggestion that they gave was just to try to aim for a more specific sensory motor experience that can basically be more beneficial to the children. So try to pick one of the sensory motor experiences as opposed to seeing this big sensory motor experience as the whole thing. Look at the development in the context specificity. Examine the mechanisms involved in develop children developing a sense of their body, and try to have studies that identify when children begin to show effects of valence in word recognition and how this is related or not to the understanding of abstract concepts. So, my topic of interest, similarly to the one presented in COGS 149, is mirror neurons, just because I had already picked that topic before doing this, and a lot of the embodiment cognition kind of and the sensory motor experience made me think of mirror neurons. So these are just some questions that arose before I started doing my research and ultimately are what's going to guide this research. So essentially, what are there similar effects of mirror neurons in children like adults? Does everyone have mirror neurons? And what happens if people don't? What kind of structural or behavioral outcomes could we see? So this is the first article that I chose. It's EEG evidence for the presence of activation, observation, execution matching system in children by LePage and Theoret. So previous studies have found that while people are observing someone perform a motor action, they activate similar patterns in the observer's brain to those that are involved in the execution of the same task. And basically, the explanation for this is the mirror neurons, which is the matching action execution and the matching um, action observation. So many of these mirror neurons were first discovered in the macaque monkeys in the premotor cortex. But because these monkeys contain very similar brain structures as humans, the monkeys are the most heavily studied, as well as adult human brains. But very few studies have been shown the presence of mirror neuron activation in children. So the goal of this study is just to try to study the MU rhythm of modulation during passive observation of hand actions in children to determine the presence of the mirror neuron system in an immature brain. So there were 18 healthy participants. They were all children. They were ranging from 4.5 years to 11 years old. The technical equipment used was an infrared emitted dioid, which the emitter and the receptor are situated at the bottom and the top respectively. And here I provided of what this technical equipment looks like. So the procedure is they basically have four different conditions. They have the rest, the flat, the grip, and the execution. For the rest condition, participants remained immobile just for 4 minutes watching the technical equipment and nothing really happening. For both the flat and the grip conditions, the participants had to observe the experimenter either move their extended hand towards the equipment or perform the precision grip. So for the execution condition, this is where the participants then had to execute this themselves at the same self-paces precision grips that were similar to the experimenter in the grip condition. So this study used EEG and it was sampled at 250 hertz and the range of the frequencies was set to and the range of frequencies that were transmitted were between zero point zero 0.01 and 100 hertz. So this method of analysis was chosen just because one, it best matches the previous studies that have been done on adults, and just because we want to see that comparison between mirror neurons in adults and this children, which are classified as an immature brain. And yeah. And number two is because it's the best at giving precise info frequency that is modulated by the execution condition. So mirror neuron areas should be sensitive to execution and observation actions. Two clusters of four electrodes were selected for this analysis, and they are basically those two. The four electrodes were in areas where mirror neuron systems are typically seen in adult brains. So the results from this is that in total, there were 15 that were finally counted for the results as opposed to the 18 that were participated, just because three of the subjects were rejected from the analysis because for various reasons. Um, Average MU bands was 9 to 11 hertz. When observing a grasping hand, both hemispheres induced stronger MU suppressions than observing a flat or at rest. So this demonstrates the earliest presence of motor resonance mechanism in children. The pattern activity of MU reported in children is similar to those reported in adults, which is essentially what this study kind of wanted to see if the children have mirror neuron activity in the same regions that adults do. And so this graph I provided here is just showing the lack of correlation between MU rhythm modulation and age of participants during passive observation and hand movements. So as you can see, they typically have this system of mirror neurons fairly quite like early on, and this isn't kind of the type to be progressively an age where this is developed. Like we have this mirror neuron system, and we use it at this age, this 4.5 to 11-year age that they studied. This next study is understanding the emotions in others, mirror neurons dysfunction in children and autism spectrum disorders. So this is now aiming at the question is does everyone have mirror neurons? And if some people don't, what are some structural and functional behavioral differences that we're going to see for these people? And this is by DePrado Davis et al. So this article starts off by mentioning that it was recently proposed that a dysfunction of mirror neuron systems in early development could ultimately give rise to impairments that are characterized from autism spectrum disorders. So some of these deficits include characteristics of imitation, theory of mind, and social communication. So mirror neuron system is a concert with activity in the limbic sisters that modulate our understanding of the emotional states of others. So previous studies have found that the insula acts as an interference between the frontal component of the mirror neurons and the limbic system, enabling the observer to translate what is being observed from facial expressions, etc., to internal emotion significance. So, being able to attribute meaning to what is being seen or how they are going to express that, um, what is being seen. So, the goal of this study is to investigate the neural activity during imitation and observation in facial emotional expressions using event related fMRI. So for this study, they used 20 participants. There was 10 children with autism spectrum disorder and 10 that are classified as typically developing children. The stimuli consisted of 80 face expressions with 5 different emotions. The 5 different emotions included here is anger, fear, happiness, neutrality, and sadness. The faces were presented for 2 seconds, and the subjects were either told to imitate or just observe the faces. Some of the results for this article for the imitation of the emotional expression were that developed kids activated neural networks that were similar to previous studies seen in adults. So there was a bilateral activation of the striate and the extrastriate cortices, the primary motor and the premotor regions, the limbic structures, and the cerebellum, as well as Brodmann area 44 and 45, which is a site that is previously identified to contain a lot of mirror neurons. Um, Autism spectrum disorders contain a robust activation in visual cortices, the premotor and the motor regions of the face, and amygdala. So they were able to attend and to initiate facial expressions. However, um, the autism spectrum disorders showed no activation in the mirror neurons areas pars apicularis. And this is basically the area where we mentioned before how there's this insula that connects the frontal mirror neurons to the limbic system in order for you to actually contribute meaning to the facial expressions. So the comparison between these two is that the typically developed children demonstrate a greater activation in the frontal component of your mirror neuron system, in which the insula and the limbic system are active. And autism spectrum disorders show greater activity in the left anterior, parietal, and the right visual association areas. So activity in the right pars apicularis during observation of facial expression was stronger in typically developing children, where they did not see this in autism, these mirror neurons activated in autism spectrum disorder. So they wanted to further examine the relationship between activity in the regions of the mirror neurons property and the symptoms of the severity of autism spectrum disorder. So they found that there was negative correlation between activity in the pars apicularis and the children's scores on social subscales. There's also a negative correlation between the activation in insula and the limbic system and the symptom severity. Um, so the greater the activity in the critical component of the mirror neuron system during the imitation, the higher the children's level of functioning in the social domain. And then here I provided the Paris opercularis activity as a functional of the symptom severity. So now I'm going to provide insight and value of my independent research. So I have 2 questions. So why is research in this subject matter important? As I was reading the article, I noticed that I had already done my other presentation as mentioned on mirror neurons, and just I made a lot of connections between embodiment to cognition, the sensory motor experience, to mirror neurons, like as I was reading it throughout. And some of the examples that I found that were relatively that made me think of mirror neurons was when our reading for the class stated that sensory motor movements evoked when learning uh, sensory motor movements evoked when learning are reactivated during recognition. And so this kind of made me think of mirror neurons. And also when Wellesby and Paxman gave the sensory motor actual definition, which is experience involving an action performed on an object by child or through observation. And kind of looking back to the um, the definition given to embodiment of cognition, it's basically stating that embodiment cognition was basically a theory that just emphasized the importance of this sensory motor experience and that has to be gained through interactions with the world. And comparing that to mirror neurons, I feel like it's really important and they're really similar. And I feel like um, sensory motor experiences through interactions is needed for both mirror neurons and embodiment cognition. So I feel like they just kind of fall under the same category. So with that being said, I think this is a really important thing to study mirror neurons just because research can provide more insight on the development and of language as well as action music and just a variety of different things. Does your topic draw interest upon certain subfields of cognitive science? Yes, neuroscience, just because it involves a lot of subcortical and just different regions involved in mirror neurons itself, as well as all of these papers involved brain regions, as well as diverse neuroimaging methods. Like, for example, the first paper was EEG, and this last paper with autism spectrum disorder was with functional MRI. Um, and yeah, so that's it for my presentation. I hope I don't have, I can't get any questions, but yeah, thank you for listening.